What's going on, guys? It's the Unhinged Engineer back with episode 6 of our graduate school vlog. So if this is your first episode, welcome. I'm going to grad school at night while I work my full-time job, and the program I'm in is computer science at Georgia Tech. It's a master's degree. And so I'm doing the second project of my first class. The first class is titled AI Techniques for Robotics, which is great for me because my specialization is in perception and robotics. And the second project that I'm working on is about particle filters. First project was on Kalman filters, same kind of general subject of like localization for robots or autonomous agents and whatnot. And so, yeah, I'm a decent amount of the way through this project. I haven't completed it yet. It's been a little bit of a struggle for me, which I'll talk about in this video, and then probably more so once I've actually completed the thing, which will hopefully be by next episode, by next week. But yeah, also apologies that this episode is coming a little bit late. I was out of town for the weekend, and honestly, I've just been slogging away at this project, so I didn't have a ton to report on. But yeah, for this episode, I figure I'll just share the progress that I have made, as well as some of the other things that are kind of looming off in the distance that I have to juggle along with the project itself. But yeah, without further ado, let's get right into the main subject of this video, which is on particle filtering. So the main application we're looking at for Kalman filters, particle filters, whatnot, is localization. And so in this setup, we have like a satellite orbiting a star that we're expected to localize using a particle filter. And the first part of the project is just about the position of the satellite in its orbit. And then the second part is about its orientation. And so you're given different sensor measurements for each that will affect how you resample and weight different particles. But in the broad scheme of things, the setup is the same. You have a satellite orbiting star, you spawn in a bunch of satellites, you propagate them all through fake orbits, and hopefully through some intelligent resampling procedures, you converge on the actual one, right? But yeah, so at this point, I have a solution to the first part just on position, but it's actually too slow. So you're given a number of time steps that your system has to converge within. That's 300 time steps. Each one's supposed to be like a day of orbit. And then you also have a CPU time limit that you have to converge to that position within the given amount of time. And so for us, it's 15 seconds. My minimum viable product of a particle filter is just enough that if I brute force it with a crap ton of particles, it eventually converges, which is part of why they have the time limit there. I understand that, and I think it's pretty smart. What I mean by minimum viable product is I have the initialization, so spawning in all different satellites. I have the importance weighting, so you take a measurement from each of the satellites and then compare it against the measurement you get of your actual satellite. So even though you don't know its position, you have other sensor measurements that you can work with. I don't want to talk about the specifics because we're not supposed to share the intricacies of the assignments, at least until we're done with the class. But yeah, you're given sensor measurements, and so you can know what you're getting from the satellite, as well as what you're getting from all your particle satellites, and basically within some Gaussian distribution, you can know how likely the measurements you got are based on the measurements you want. You want them to match the real thing, right? Because that means that your positions are the same. And so I have that importance weighting in there. I have the resampling in there, which if you saw my last vlog, I mentioned that the resampling wheel was a little confusing to me. If you don't know what I mean by wheel, check out that video. But basically, it's just a strange way of making sure you're pulling resampling particles based on their weighted average, weighted by their probabilities, right? So you have a bunch of satellites that are randomly distributed, usually a uniform distribution, and then you're trying to fit them, you're trying to resample them based on each one's likelihood, right? So I have that resampling done. I have the motion step done. The motion step does actually follow the bicycle motion equations that we were given in the last episode. I talked about them. Yeah, I at first didn't really see how they related because bicycle motion doesn't sound like something you'd apply to satellites, but anything that's going in a circle, it works. So that was good. Excuse me. And then lastly, the actual estimation, which is for me right now, it's just taking an average of all the positions of the particles. So the idea is if over time only the particles that are getting closer and closer to the actual satellite are being resampled, then the average should converge towards the actual satellite's position, and it does, right? Even though it's too slow, it works. And so, yeah, like I mentioned earlier, I understand why they include the limit, because now I have to get all the fancy shit out, right? So by fancy stuff, I mean being smart about the initialization. And I kind of do actually use like a pretty intelligent initialization setup. I'm only initializing particles in a way that makes sense, right? And so that one's probably needs the least improvement for right now. But in addition to that, I have to like tweak the sigma parameter. So if you talk about that Gaussian distribution, it is the same sigma you're thinking of, where like it determines how wide that distribution is. And so if you really like spread out that distribution, you're kind of being more forgiving. So higher sigma, you're being more forgiving about like, okay, like maybe it is somewhat likely that you could get this measurement based on the ground truth that I have from the real satellite. And so that's great because like you can handle more noise, but the contrast is it takes longer to converge because you're not resampling as aggressively, versus if you like tighten up that Gaussian distribution, then you're being harsher about, okay, like if this thing isn't really close to the ground truth, then I'm just chopping it. I'm just getting rid of it, right? And so that is great because it converges faster, but the downside there is that, you could converge to like the wrong position, and that's bad. So, I've gotten a few cases where I run it with a tighter sigma and it, doesn't converge correctly, but it is definitely faster. So, it's a trade-off there, and that's something I work with. But I think the main lever that I really need to pull is like fuzzing. What I mean by fuzzing is honestly, I haven't implemented myself, so I'm not an expert on it yet. Not that I'll be an expert by the end of the project, but you get the point. But fuzzing the positions and the motions of these satellites, like kind of imparting some noise on the particle filter, right? Because fundamentally, the particle filter is just a method of like simulating what you think the motion of what you're trying to localize should be like, and then resampling the results of those simulations in an intelligent way, right? And so it's kind of like how, Dijkstra's algorithm is a breadth-first search with some intelligent data structures wrapped around it that make it such that the shortest path is easily accessible by the end, right? Like you have like a really basic concept of just, okay, what if I simulate the possible motions of these things, and then you wrap it in some more intelligent statistical things, and ultimately it works out, right? So fuzzing just imparts some noise into the actual simulations, I'm calling them, themselves, and I haven't really done it yet. So once I do that, hopefully it helps a lot, and they do mention explicitly like you should be doing fuzzing, so I'm not like being led astray here. Like I know this is something that they want us to do, I just haven't gotten to it yet. But yeah, tonight there's actually like a tutorial session, which is part of why I'm recording this in my post-work like energy dump. But yeah, I have a tutorial session tonight with one of the TAs. They did one of these for the Kalman filter as well, but to be blunt, I was getting a little arrogant, like I'd gotten very far along in the Kalman filter, and I kind of just knew what I had to do, so I just like opted to bang it out instead of go to the TA thing. But for this one, I'm going to be a little more humble. I could definitely use some guidance, especially in regard to the fuzzing I just mentioned. So I'm going to go, and then next episode, in addition to hopefully the completed results of the project, I'll also have like a review of how the TA review went. So yeah, and the project itself is due the 25th, and I'm recording this on February 11th. So I do still have a good amount of time. Like I'm not worried. I'm confident that I'll get it done. It's just like this one's been a little bit more of a slog from the Kalman filter, because I was more familiar with the Kalman filter based on like some of the control systems things and other internship experiences I had before, as the particle filter is kind of like new to me. So it's been a little bit more of a slog, but I think I'll get through it and it'll be all right. Unfortunately, before this project's due, I also have some other things I have to get on, which is going to be part 2 of this video, right? So for one, I have problem set 4 due. Problem set 4 is about search, which I haven't actually watched the lectures yet, but it seems that it's about like motion planning, dynamic programming, like search heuristics like you would have in A-star or whatnot. It seems pretty interesting. I'm excited for this chapter. But these things are due February 17th, so they're still due before the project. So I got to get on them, even though I'm trying to juggle multiple things. But 2 things to note. Number 1, it's not on the midterm. So once I get the problem set done, I'm probably just going to move on for a little while. But number 2, the search project is the biggest one, both in terms of workload and like grade weighting for the entire class, right? And so like I want to get started on that as soon as possible. Yeah, my point here being I'm going to get on it. I'm going to finish the problem sets probably, well, I have to by this weekend. The problem sets have never been like a huge lift, so it's mostly just going to be a matter of like watching the lectures and doing what they tell you. But yeah, then hopefully once I've made more progress on this project and the midterm, which I'm about to talk about, then I'll focus on that as well. Speaking of the midterm, that's the 28th. It's the weekend of like the 28th to the 2nd or something, which is like right after the particle filter project is done. And obviously I want to start studying for that midterm before I hand in the project is due, like before 3 days out from the exam. I might eat these words, but I feel pretty good about the midterm. I think this is a very like project centric class, and the projects have been hard. Like they've definitely stretched my knowledge of the material, both with the Kalman filter and with this one for sure. And so like, I like the lectures. I'm going to review them. I have detailed notes from all the lectures and stuff. Like, I feel like as long as I give myself enough time to adequately prepare, it should go smoothly, fingers crossed. And if it doesn't, then I'll definitely kind of wince at this video later on. But yeah, it's just something to note because, again, like I'm starting to juggle different things. I got the project, I got the problem sets, I got studying for the midterm, and then all the other crap I have going on in my life. So yeah, it's getting a little hectic right now. Apologies again for the late upload, but just wanted to share my progress so far. Thank you so much for watching. If this is your first video with me, welcome. Thank you so much for tuning in. I'm the Unhinged Engineer. I make professional development content for software engineers, aerospace engineers, basically anybody trying to work in technology who's a young professional like me. If you could use a little guidance or just somebody else who's venting about your same problems, then this is the channel for you. Yeah, thanks a lot for watching, and I will see you in the next episode.